So, why am I talking about a moon rover? Basically, what happened is there was a competition from NASA called Find Me on the Moon. And they have low-tech navigation thing where it's like, make something that will let you navigate around the south pole of the moon from a moon base with an astronaut that has no electrical power whatsoever. It had 10 prizes. I think the biggest one was like $4,000 or $5,000 at the bottom. So I thought, I'll play the odds, 10 prizes, I should get something. I spent 2 months designing something kind of like the VOR system for navigating aircraft, except all optical and all used in full-rise light. Put a lot of time into it, relearned my high school trigonometry, all that fun stuff. Kind of several factors on it were like F, but the rest of it was pretty solid. I got honorable mention, $250. The secondary prize, which was only 3 prizes, the top one was $20,000, then $10,000, then $5,000. And that was make something that can get to the bottom of Shackleton Crater, get samples and bring them up. It can be astronaut tended, it can be independent, whatever. I only put in a month. I only put in 2 crappy illustrations, and I won. Now, of course, my furnace decided that was a great time to die, which meant that was a great time to pay for it, but easy come, easy go. So anyway, the bottom line is that's where all this came from. But it's because it is robust enough to get to the bottom of Shackleton Crater, it's robust enough to work on pretty much anywhere on Mars. So this is the Viper rover. This was, last year it was canceled, this year it was reinstated. This is supposed to go to exactly that region. It is very low budget. These wheels can track up and down about 1 diameter, but they are manually adjusted from somebody in a control room because it's very low budget. It can slide on its belly if it has to, but it's got this sort of paddle wheel arrangement with the lamp wheels, but it's exceedingly challenging to get down there. You see how steep that slope is. This is, the bottom of this crater has been close to, if not lower than, the temperature of Pluto for billions of years, or however long it was since it was created. By the way, if you're thinking of designing missions for Pluto in 100 years, this is where you practice. We'll have that technology way before we have it right, because we'll have experienced it. But it's the equivalent if you, like, there's easy slope, medium, double diamond ski slopes, whatever. This is the equivalent to a medium, approaching a hard slope from a skiing perspective. And lunar soil at the equator, where we had the Apollo missions, it's gritty, it's got ceramics in it, it's got little metal pieces that never got worn out by water because there was no water. Glass that's broken the same way. So it tears up any kind of seals or anything and anything. It's because of the static, it adheres to materials the same way. That's what we know about from the equator, where it's nice and dry and warm, and it's been cycled to where it's desiccated to a degree. Pole, we don't know anything about it. So, and the consistency of this is if you push, it's like soft snow. If you push on it when it's powdery, it just goes right down, but once you get it hard and packed, it's like plaster. And that's all we know from the equator. So I tried to make a modular design that was very practical. Everything is highly redundant. Everything is very repetitive. One thing is, if you're sending a signal down to something in a permanently dark crater, light is your friend, because there is no light. If I shine a laser on a rock in front of me, you can see that for miles in any direction. If I use a strobe light and I put a little code into the strobe light, the same way you have an infrared remote for your TV and you push the button and it goes, and you can see it on your camera because the camera can see the remote, see infrared, and it makes that little flicker. That flicker is the code saying go to channel 27. You could do something like that with a strobe light here, and anything along the rim will see it because it's the only thing down there that's putting out any light. So the idea here is you have laser communication. You'd also have AM and FM systems because the waveforms are so different that the wave will go above or below anything. And then there would be a mesh network between the systems. So laser, AM, FM, and this strobe system. Because you don't have to see the rover, you just have to see something the rover can see. And you could also shine a light in front of the rover to send the signal back. make the problems work with you. Secondly, we've got our modular half points, which are all these little guys here. This little brick size thing. These are one of those crappy illustrations from the original present. These are basically, on the International Space Station, the arm is not permanently attached to one spot. It actually has connectors on both sides, and it can inchworm from one place to another. And each of those ports where it plugs in provides power, data, and the structural strength to lock it into where it can actually move loads around. So those three factors, it's like, well, that's a good system. Let's just duplicate it here, put a bunch of those around the rover, and then we can stick whatever equipment to it. Plus, these hard points are heavy bolted systems, so they'll be able to handle a lot of weight. So you can pick up the rover by it or stack rovers together. The other thing I wanted was something that's small enough to fit through an airlock, because if you want to bring it in for servicing, then you don't want to have to make a special hangar for it. You want to just be able to flip it up and move it through. So that dictated the scale. That slope problem, because it is modular, that's the grade, and that's the average grade, is 25 degrees. So not a double diamond, but pretty vicious, considering we have no idea what the surface is made of. So part of the reason I think I won this is I actually know a lot about the history of exploring the Antarctic and the Arctic. This was called the Antarctic Snow Cruiser. Raise your hand if you've ever heard of it. Exactly. 1937. The scientist who designed this, the engineer, went on an expedition with Admiral Byrd. He figured out how much pressure you could put on snow. And I think it was like 15 kilopascals or something like that. And basically he said, if I make a rover that's half that load, I can drive that all the way across Antarctica. Remember what I said about the other thing being able to raise and lower the Viper? It can raise and lower the tires. It can slide on its belly across the crevasse, whatever. Exact same thing in 1937. These tires raise and lower. It can slide on its belly across the crevasse. It was designed to do that from the get-go. So they could go crevasses about this much of its width, because they knew there were cracks in the ice. This was going to go all the way across Antarctica. They were going to put a biplane on the back of it, scout ahead, take pictures, come back, develop the film in a dark room in the nose of that in a 4-man crew, and then go all the way across. It had spare tires, all that. So the idea was this thing would just get cut loose on one side of Antarctica, arrive on the other side of Antarctica. Problem. It got stuck real fast. Because the engineering that said, I can handle this much weight on snow, did not take into account the fact that when you spin a wheel against it, it's like tearing apart a house of cards. It rips the structure of that snow that would handle that weight completely apart, and then once you're stuck in the snow, you're going uphill. And we all know that walking uphill is harder. Turn the treadmill on just 2 degrees, you'll know that that's a lot harder. So it was fighting that all the time. It ended up being 10 times heavier than it could possibly be, instead of half the weight that it could be. The math to do that, in that guy's defense, was not invented for another 15 years. So they doubled up, they put the chains on the back tire, they put the double tires in the front, they did every trick they could to expand the traction of it, and it got 3 miles. It functioned as the control tower for that plane, because they were still using the plane to supply dog sleds and things like that around the base. And then they also basically, they said it was the most comfortable accommodations on the entire continent, because it had all the heating system and stuff. So they still got good use out of it, but it ended up, they left it behind. It was on a glacier, it got pushed out into the ocean. It's probably on the bottom of the Atlantic Ocean. So somebody came along in the 50s and 60s and came up with this, which is a land train. And they made 5 different versions of it. The largest was the largest land vehicle ever made by man. It's about like a kilometer long, practically. Every one of those wheels has an electric motor in it, in the hub. It's powered by 2 big diesel generators. These were the same principle, just much smaller. This is what they used to build the distant early warning radar systems in Alaska, Canada, and Greenland to get out there. Because with all that, it's 10 times bigger. That means you need 10 times more tires. I'll go 28, whatever many cars are there. So I went on the same principle, but I went one step further and I had Caterpillar tracks for each one. And then you use these couplers, this same modular coupler, as your train connection to go from one to the next. And then, so I went through what else. We have this modular system, which means we can kerbal this thing together and do whatever we want with it. So one concept with this is my second crappy illustration to the original post. It's having these cultivator wheels. Somebody called me out on it. That actually is a cultivator wheel on SketchUp because I had a week to throw this pretty graphic together because what I won, it was like, do you have any better pictures for the press release? I will now, because I had to throw together, I had to reword SketchUp because I hadn't used it in 10 years. So I was able to throw this together in SketchUp. These are, the idea here is that when the Spirit and Opportunity rovers were going around, they would get caught in what Chris McKay called rover traps. They'd have this really thick, or thin, hard crust on top of the surface that looked like a perfectly flat surface for driving. They'd start driving on it, perfectly solid, everything's good. Underneath they had a layer of talc about like this. It was just like super soft sand. So it'd drive out on the thing. Once the full weight of that thing got out, it would fall through the surface, like falling through a pond. And then it would try to dig it out. And remember what I said about it's really hard to climb out of a hole? It's really, really hard when you're climbing out of talc. So they get stuck for weeks, as you may recall at that time. So the idea here is each of these pins puts down exactly the same pressure as the weight of the vehicle, passively. So if that pin goes chunk, don't keep driving. And you'd have an AI basically that would say, wait, stop, and call it out. The funny thing about this being with robot arms is that if you got into a situation where you could detect the sliding, if it starts drifting, you could feel the pins moving. The third thing is, if you got sort of a vestibular system in there and it starts sliding on it, you could take those things and just go like a cat and just drive them in as hard as they can as a fallback system. Because falling through is one thing, sliding down the hill is not. This is how, remember we were showing those ski slopes? This is the traditional vehicle for driving on a ski slope reliably. That's how wide our track is. So we can extend our tracks out a bit. This is something that happened in Greenland. They were trying to run a caravan of vehicles up onto the ice cap in around 1958, 60, somewhere there, because they wanted to build a base on top of the Greenland ice cap. And the first time they did it, the vehicles didn't have a traction. So they went back to the shop at Thule Airbus, which is still there, and they extended the tracks out. They just welded new pieces under the end of each one. So we can't really weld them, but we can, we don't want to do that level of fence. So we built it from the get-go, where each track has the bolt holes to extend, just add to each one. So if you need it, you got it. It's in the kit of, in the Batman utility belt with parts you can slap on this thing. So solution 3, what if we had an anchor cable when you're about to go through something really harsh? And we could run it all the way down if we wanted to, but we'd have to have a reel for the cable on the rim, and then play it out. Once you've used up that reel, bring in another reel, because you're not going to carry it all on the rover. And then once you're at the bottom, just post, keep it up, elevate it out of the regolith every so often, kind of like a cable car, and then have this mechanism, make some mechanism up here that's designed to pull that cable all the way through, and then climb the cable just the same way you would climbing out of there, like on a ski slope. The rope lift, same concept, except you're doing the lifting. So another thing is, if you've ever seen ice climbers, they have these special axes, and if they start sliding down the ice, they can just go, and then they'll have enough penetration to get into the ice and stop themselves from sliding. This is called a snow anchor. Similar principle. and they use these for rappelling down glaciers. So theoretically, if you had enough dust or something, or you could just lock it in somewhere, you could have something like this. You could either set it up preemptively, or you're sliding, just drop it out the back. Again, modular release system. And then, of course, if all else fails, you could have your roll cage, which is why I got the name Lunar Halo in the first place. Lunar Halo means a ring of ice around the moon that you see in cold weather. This was the idea, it was like a halo over it. But then you could also put cameras and strobe lights and whatever else up on the camera. So if it does roll over, it would have a tendency to fall back on the tread as it came to rest. So how would we adapt this for Mars? One thing the Martian expeditions do normally is they will go back and take a picture of their tire tracks to look for things that they unearthed. What I would do with this vehicle is I would have cameras automatically there and an AI system that would basically say, I don't recognize that, or I do recognize that, and I can quantify it. And basically, anywhere this thing drives, it's getting geomorphic data, whether it's around the base or in the crate. So on the moon, one thing is, because it is modular, you don't know how many batteries you're going to need and how long you're going to be at the bottom. So you would carry power packs and stuff as cargo on top of that thing. Same concept here. You could use it for setting up a solar farm or whatever with Optimus robots, sort of as the packing or that sort of thing. We could have, there's lunar lava tubes, there's Martian lava tubes. You could probably use that modular system to lower it down to the bottom via a crane or something, or just go over the edge. Good for crew-tended equipment swaps or robotic if you've got, again, Optimus robots or humans, doesn't matter. Those things you're packing into that sort of thing. And then on the moon, you can have a system with microwaves that actually shoots microwaves into the surface and stabilizes the ringlet. You could do something similar here with a stabilizer. And then you could also test for sand traps. If you're about to do a long traverse with crewed vehicles, you could send this thing ahead a few days early to say, okay, there's treacherous stuff here, let's just make sure everything's clean. And then it's big enough you could actually put a seat on the back if you really wanted to drive the thing down. So it's a bit like if you've seen when they do remotely operated submarines and they have a big ship at the surface and they're running them with joysticks all the way down into the perfect darkness. It's going to be that kind of vibe for a lunar base where you're sending these down to the bottom stack, but you're not necessarily sending people because it's so insanely cold. But if you had something like this, you could theoretically put a seat on it and the seat heater to end all seat heaters on the back of that thing, and get a human to the bottom Shackleton, because otherwise you're not going to be able, you're going to freeze to death before you ever get there. So you could actually finally send a human to the bottom of Shackleton Crater if you had several of these things lined up. Got out, did like 5 minutes worth of work, climbed back on and say, okay, we planted the flag, let's go. So, and then this is just a general technology readiness level issue. I had some ideas around driving the treads with magnets. It is actually cold enough down there that room temperature or high temperature superconductors will work barely. I toyed with the idea, but it was like within 20 degrees Celsius, which means the minute the system gets hot, you've quenched the magnets. So it's like, okay, screw that, we'll just do a magnetic driven tread. By the tread being magnetically driven, there are no seals or anything. It's just, you're literally just dragging the pulling with magnet. So it's you don't have to deal with all the height, all the silos to keep the lubricants inside or all that. It's all just very, very basic. Fuel cells, batteries, pretty much everything's pretty solid. I was borrowing them from Starlink, from Patty, from Viper, commercial moon landers, Perseverance, even remote driving on the moon from the Russians back in the day. So that's about it. That's my portfolio QR code if anybody's interested. It's got all my talks for that however many years. So, any questions?
No question, but I've heard they're talking about putting a satellite around the moon and Mars for GPS. So that would solve some of your communication problems.
Yeah, it was in the contest parameters. You had to be able to do a certain level of navigation without any external systems other than, for the rim. So if you have 2 fixed points on the rim and you knew where those points were, then you could just track off those. And if it's AM, FM, and laser, then you've got, and it's not like you're teleporting a kilometer and suddenly have to find yourself again. You know where you were 5 minutes ago. So you could do a lot of, it's not gonna drift too much, yeah. Yes?
So the current and the previous Mars rovers are all sort of wheels on spider legs, whereas your proposition is Caterpillar. What kind of common discussions go into the choice of one against the other?
Basically, we needed all the tricks we could, but you see where those tire tracks are overdone? That is perseverance sliding back a slope, and that's 10 degrees. This has got to go to 25 degrees. So we already know on Mars that this didn't quite work all the way. So we needed something better than that. So if tires don't work, go to Caterpillar. Caterpillar don't work, go to extended Caterpillar. That doesn't work, go to Landtree. So basically what the idea was you go to the moon, you have like 5 or 10 of these rovers in the cargo bay, you've got kits of all the accessories you can slap on these things. You try something, if it doesn't work, try something else. You don't have to go back to Earth and make a new one.
Can you not take both? Like for example, wheels on the spider legs, but also has ski things which comes down James Bond style. Go down.
You could. Actually, I look seriously at a snowmobile drive mechanism, but it's way too mechanically complicated, which means that all those seals and things I said were going to get gummed up would get gummed up. So I had to keep the drives. That was the other reason for this. Is if it's on a Caterpillar track, it's super simple. You could just pull it with a magnet, and it doesn't have to be connected. So you can be inside, outside, completely sealed from each other.
What would you expect the range of the vehicle to be with the batteries, battery packs? And have you considered having an alternative propulsion system based on methanol or methadox, if that's what's going to be produced anyway if we use Starship to get to Mars?
For Mars, definitely. For the moon, I think I looked serious. Actually, I started with the fuel problem and was looking at methane fuel cells and stuff like that. It is a bear to find any good data on it, because whatever you do has to work at cryogenic temperatures. So I basically just said, I just punted because it wasn't in the contest parameters, and I had enough. So I did everything else except power. I basically said, there's a big brick, it's got stuff in it. I don't care what it is, it's going to power it. You need another brick? Put it on the next train car. You can stack them twice, I don't care. It's like you can quadruple your fuel supply just by putting more bricks on it. So it's in that.
How about an enormous unicycle?
Yeah, see this big brick here? The idea here was this is
Right.
cargo, but it could be one big fuel cell.
But if there was a methane or a methadox engine, I mean, you could instead have an extra fuel deposit.
On Mars, definitely.
On Mars.
On the moon, like I said, I seriously considered that. It actually gets cold enough to freeze some of those.
On the moon, yeah.
On the moon. So it's like I can't freeze my fuel supply. So, yes.
Everybody's doing wheels or wheel-like things that Caterpillar has, but off-road, legs do better than wheels. And with all the advances in the products, I'm wondering if anybody's looking at something like an 8-legged camel.
Again, I had to keep it super simple, and I was also trying to deal with the fact that the moon has so much grit that I wanted to keep it. I wanted something completely sealed so that the grit would not get into the joints and tear it apart. I did consider. What's funny is I thought, oh, if I have tungsten bearings and ceramic sleeves, that'll grind up anything. And then I looked into it. It's like, sure enough, they already did that on the poly. So it was like, so it can be done, but I wanted to keep it, it's a contest. I'm trying to grab up in the simplest.
Or is that like accordion sleeves over the joints? Like keep them steel? Something like
Well, you can't do that with a wheel though, because you're going to twist it.
No, the legs.
On the legs,
Like
probably.
accordion steel.
Yeah, that's true. But again, anything you flex, it's got to be flexible. It's not going to be super flexible at cryogenic temperatures. So I had to keep it dirt simple because we're talking like liquid hydrogen-ish within 10 degrees Celsius.
I imagine technological readiness level is also a consideration, that's
Yeah.
true technology. But my question, does ground penetrating radar
Yeah.
solve any problems of those outriggers? I know that that's not the primary function of it, they have other functions.
You can pick it up below you, but in front of you, you're gonna get a deflection pattern. So,
So that's not a viable.
not if I would still take one though, because I'd want to know what the heck's under all that mystery dirt.
Just have to.
Yeah, looking at the land train, I was just curious, what, if you're thinking about, let's say, a development roadmap for something like this, what would you say is maybe the smallest size of a wagon that you would need to kind of demonstrate that this actually works? Because I imagine this is quite a massive setup here, so, what would you think is
If I
the
was to-
first step?
I mean, if you could manufacture one of these, I think you'd probably just crank out a few of them, but again, this was purely a last minute contest entry, to be honest. I had no intention to manufacture, the fact that I won and I had to sign over the IP to NASA, so in theory, if any of this shows up at NASA, it's because I signed over. That's what I got for my 20 grand, or what they got for their 20 grand, was me signing over, so you start seeing this stuff popping up on the next project.
We'll ask
You're
them.
welcome. Any other questions?
Oh, just one more.
Oh, sure.
If it rolls over, what's your recovery solution?
Send another one and pull it out. But it's, yeah, I mean, that's why I had so many catches, is that, and you might, because let's say on the first thing, you're like, we don't need all this stuff, it's gonna be easy, and then you're wrong. You know, or the first one, you put so much crap on it that it's top heavy and it flips over. So you actually made a good point. Actually, you reminded me of the point I was gonna make, but I missed it. Have you seen these things that NVIDIA does where they do a simulation of like 1,000 walking robots and they're all stuck until they finally evolve the ability to walk properly? The idea was you would have 1,000 of these things in a digital twin, figure out what combination of ingredients were, the precise designs of those roll cages and all that. So you work all that stuff out to the best of your ability before ever going on the mission with every possible combination of surface viscosity, you know, all the various properties to handle the broadest possible range of options. Because theoretically, you could take this as is and drop it in Pluto. And so that's the idea, is that you could use this anywhere. So anything else? All right, we're at time. Perfect. Thank you.